Section 8.4, annuities. Again, we're going to continue to use our finance solver. So as we're working through these, before I start filling in the information on the finance solver, I would suggest that you try and figure it out on your own to see if you can get them put in the right spot, and then start the video again to see if you did it correctly. Find the value of an ordinary annuity at the end of the indicated time period. The payment R, so R is payment. Frequency of deposits, M, which is the same as the frequency is compounding. That just tells you that PCY is the same. The annual interest rate, R, and the time are given below. Okay, so first thing they give you is the payment. Okay, just so that we're clear on this. This is the compounding. This is your interest rate, and again, this is T. So it's being compounded quarterly for 7 years. So it's 4 times 7. The rate is 12%. This one, we'd start having payments. So we have quarterly payments of $1,000. So the 1,000 is coming out of your pocket, so it's going to be negative. When you open the account, you start with nothing in there, and future value is what we're going to solve for. So when we make payments every 3 months into this account, how much will we have at the end of 7 years? Just putting everything in. And quarterly, so that's already at 4. Otherwise, arrow all the way to the left till it's not highlighted, then you can arrow up. So future values 4293092. That's how much you'll have in the account at the end of 7 years. Find the monthly payments. So monthly payments are what we're going to be looking for. To have a sinking fund accumulate the future value A. So it says A is future value. So in the future, we want to have, that should be, I think I have an extra 0 in there. So take that off. The yearly interest rate is 7%, and the interest is compounded monthly. And it's for 5 years. So it's monthly times the number of years. And we're looking for the payment. When you start with the account, you're going to have $0. How much do we have to put in every month to have $8,000 in 5 years? Right. Arrow to the left until it's not highlighted, then you can arrow up to payment, and I hit enter. So $111.74. Again, you're just going to ignore the negative. That just means it's coming out of your pocket. Use the formula for future value of an ordinary annuity to solve for N. So we know we're going to look for N. When A is equal to 5,000, so A is your future value. Okay. Payment is $550. The interest rate is 6.25%. Present value would be 2. Okay, and this one doesn't tell you how often it's being compounded, so you're going to have to assume annually. So that's going to be 1. Okay. So this one we're solving for. And we assumed 1, so arrow to the left if it's not highlighted. And we're solving for n, so I'm going to keep arrowing up and hit enter. 7.42. It says round up to the nearest integer, so you have to round up. So that's going to round up to 8. The rule of rounding would say set round that to 7, but it says round up. Matt is saving to buy a new motorcycle. If he deposits $65 at the end of each month in an account that pays an annual interest rate of 3.5%, how much will he have in 60 months? Assuming compounding is done monthly. All right, so 60 months. Divide that by 12, and that's going to give you 5 years. Make that a little bit neater. All right, so he's putting in $65 each month. The account is open, there's nothing in there. And how much will he have in 60 months? So we're solving for future value. $65 each month. How much will we have in there? PCY is going to be 12. Arrow to the left until the highlight's gone. And then you can arrow up. And I want to solve for future value. 42, 55, 30. Oops. That's how much he'll have in there after 5 years. Suppose a woman has decided to retire as soon as she's saved $650,000. Her plan is to put $500 each month into an ordinary annuity that pays an annual interest rate of 5.3%. And how many years will she be able to retire? So where would this $650,000 go? That's in the future. That's how much she wants to have saved so that she can retire. Her plan is to put $500 each month into an account. So each month tells us that it's being compounded monthly because your payments per year and your compounds per year are going to be the same for us. All right. She has an annual interest rate of 5.3. When she first starts, she had 0. We're going to solve for n so we can figure out how long it's going to take her to save that money. Let me double check what I put in real quick. All right. So we're solving for n. We want to know how long it's going to take her to save the $650,000. So 433.02. So is it 433 years? We solve for n. So think about that. We're going to have to divide that by 12 because it's being compounded monthly. So n is actually your PCY value times 12. I'm sorry, your PCY value, which is 12 times the number of years. So when we take the 433.02 divided by our PCY, which is 12, it leaves us with a number of years. I would go to 2 decimal places. That's worked for me every time I've worked these. So that's going to be 36 years. She can retire in 36 years. Kanye wants to save $25,000 in 12 years by making monthly payments into an ordinary annuity for a down payment on a condominium at the shore. If the annuity pays 7% monthly interest, So let's look at that. What will his monthly payments be? So first of all, what will his monthly payments be? That's what we're going to be solving for. And monthly tells me it's 12. And it's 12 years. So where does the 25,000 go? It's in the future value. So in the future, he wants $25,000. Present value is going to be 0. Now, this is the monthly interest rate. The interest rate here is the annual interest rate. So you're going to have to do that and multiply it by 12 to make sure you have correct numbers in your finance solver, because the finance solver wants the annual interest rate. Right. My PCY is already 12, so I'm going to arrow up solve for payment. So it's $101.13. So just be careful on that one. They have the monthly interest rate. The Reliance Volunteer Company wants to take advantage of a state program. Check something real quick. To save money to purchase a new fire truck. The truck will cost $485,000. The member of the finance committee estimate that community and state contributions, they can save $8,500 per month in an ordinary annuity paying 10% annual interest. How long will it take to save for the truck? So we know it's $8,500 per month. Per month is going to be 12. It's asking how long, so we're going to solve for N. The rate is 10%. So where does the $485,000 go? They want $485,000 to buy a truck. That's going to go in future value. So let's put all this in. And we said it was monthly. So we need to find N. Arrow up. 46.87. All right. But again, N is 12 times the years. So we're going to divide this by 12. And take N out to 2 decimal places, and you'll be fine as far as rounding and whatnot. So hit escape. So 3.9 years. And check the rounding on that. I don't remember if it was 1 decimal place or if it was a whole number. So let's look at this. This is our last one for this section. At age 21, Julio begins saving $13.25 each year until age 40, so 20 payments. And in an ordinary annuity, paid 5.5% annual interest compounded yearly, and then leaves his money in the account until age 65, so 25 more years. So for 20 years, he makes payments, and then for 25 years, he doesn't make any payments. It just sits there. So we're going to have Julio on the left. His friend Max begins at the age of 41, saving $2,500 per year in the same type of account until age 65, so 25 payments. These are just annual payments. How much does he have in his account at age 65? So let's look at Max first. Okay. So I'm going to go over to the finance solver. You may want to write this down. So let's look at Max's scenario first. This is a little more straightforward. All right. So he makes annual payments for 25 years, and he's putting in $2,500 per year. And what's the rate here? 5.5. So annual payments is going to be once a year. So again, arrow to the left, what's not highlighted. We need to find out how much he's going to have in that account when he's ready to retire at the age of 65. So 1, 2, 8, 8, 1, 7. Just put a comma there so I can compare it. So that's how much Max will have. So he started at a later age saving. Now Julio, let's look at his scenario. All right, so he made 20 annual payments. Same account, but he's only putting in $1,325. So we're going to hit enter. So, and then he stops. So the account has $46,200.52. But what happens after that? Okay, first he makes 20 payments, and then it sits in there for 25 years. He doesn't make any more payments. So let's look at that scenario. Again, I'm going to hit the wrong button. So it's going to sit an additional 25 years. So we're going to do this again. Okay, so that's how much he has in the account. He's making no payments, and we're going to have to figure out the future value. So the first 20 years, he makes payments, and the balance in the account is $46,200.52. Then that money sits there for 25 years, making no payments, but it is accumulating interest. So this is the total he has in his account when he's ready to retire at age 65. Look at the change on this one real quick. 71. So this is how much he actually has when he goes to retire. All right. So starting at a younger age makes a bigger difference. And Julio was putting less into the account than Max actually was. Yep. And this is it for section 8.4.